All right, it's time to learn my least favorite thing in AP Calculus, which is something called the quotient rule. And a quotient is just a fancy way of saying a fraction. So with the product rule, you were looking at two things being multiplied together. With the product rule, you're looking at two functions that are being divided by one another. And it follows this really catchy saying, low d high minus high d low all over low squared. So the first thing you should always do when you have to take the derivative of something like this that's in a fraction form is think, okay, I have a 1 on top. This is called your high point. Actually, there we go. This is your high. This is your low. And then off to the side, I write high is equal to x squared minus 3x. D high, the derivative of the high, is 2x minus 3. My low is x. And my d low, the derivative of just x, is 1. Now that makes the formula a lot easier to do. So the quotient rule, I'm going to give you the technical definition, and then I'm going to give you the catchy way of saying it. Actually, the other way around. So you always start with low. So low, and I always think, okay, you start low and then you get high. No one is born high. Everyone starts low. You start at the bottom of the mountain, you go up to the top. Starts low. So always start with low, because that's how the function is. Low, d high minus high, d low. Low d high minus high d low, all over low squared. So what this actually is saying is the 1 on the bottom, which we're going to call g of x, times the derivative of the top one, so we're going to say f prime of x, minus high, which is f of x, times the derivative of the 1 on the bottom, which is g prime of x, all over low squared, which is g of x squared. So these two are the same thing, just put into more complicated terms. And again, it doesn't matter if you say g or of t or f of h, or it doesn't really matter in the long run. So, but we already got our highs and our lows, so this will work. So this works. You can use this form. They're not going to take off points if you write it out like that and then use it. So we're going to do it. Y prime is equal to low. Again, my low is x. So x times the derivative of the high. So d high is 2x minus 3 minus my high, which is x squared minus 3x, times the derivative of my low, which is just 1, all over low squared, which is x squared. Now, it's time to go into more detail. This becomes 2x squared minus 3x minus, put this x squared minus 3x, and put this in parentheses because this is now a double negative, all over x squared. You'll see what I mean. So this becomes equal to 2x squared minus 3x minus x squared plus, because it's a minus, so this becomes plus 3x all over x squared. Now we have to combine like terms. So 2x squared minus x squared, this becomes x squared, so 2 minus 1. And then minus 3x plus 3x, these are just going to cancel. So it's x squared over x squared, which you know is just 1. Okay. Now I'm going to do one more model problem that you can follow along with. I'm only going to do half of it. The rest I feel like you are going to be capable of doing. So, in calculus, or in physics, I mean, which you already hopefully remember so much about, you learned about this AVX diagram, AVX. So whenever it's talking about acceleration, velocity, or position, you can use this little diagram. Right now we're only going to use one side of it. If I'm going from position to velocity, I take the derivative. And the same thing if I'm going from velocity to acceleration. So this one says, the velocity of a particle moving along the x-axis measured in meters per second can be modeled by the function v of t is equal to t over t squared plus 1. And it wants us to determine the acceleration. So again, that just means take the derivative. Now, the first thing you should do, v of t is equal to t over t squared plus 1, is determine your high and your low. Make that less ugly. And I want you to write them always out to the side. So, high equals t. d high, the derivative of the high one is 1. Low say 2t. Now let's plug in our function. So it is low d high, or I'm going to say a of t is equal to low d high minus high d low all over low squared. Actually, let's get us into good habits. Technically, while it is a of t, we're going to say v prime of t. That looks like it's there's that low squared. Now, I'm not going to do all this. I trust that you can figure this out. And then again, so going back to what derivatives mean,